I'm ready to go. Thank you.
And thank you for joining us on Microsoft Teams. Sam, pleasure to have you with us. Look forward to hearing more about the Privacy Sandbox.
Yeah, thanks so much. So yeah, I'm Sam Dutton. I'm a developer advocate with the Chrome team based in London. So thanks for joining today. I was actually thinking about, I'm sorry, I'm going to mispronounce this, Aarhus, I don't know, whatever. Anyway, and I remembered I'd actually done a talk there about WebRTC, and then I looked it up and I found it was nearly 10 years ago. Anyway, that was like when I had black hair. That's what, yeah, WebRTC did to me.
You're
Anyway,
always
I remember.
come back to our house to
Right, yeah, our house. That's it. Yeah, that's nice. I like that. Anyway, I want to get back there one day. I remember, yeah, it's just a lovely place. I particularly remember the art museum, actually. Anyway, enough of that. So I work here now at Google in King's Cross in London. We have a lot of the Chrome team here, not least most of the engineers who build Chrome for Android. Over the past few years, I've been spending a lot of my time working on the Privacy Sandbox initiative. That's what we'd like to tell you about today. Also, I want to give you some insight about how Chrome rolls out new features. We may run out of time for that, but if we have time, I'll go into that in a little more detail at the end of the talk. So that's how we get from canary to stable, because that's really fundamental to understanding a big project like Privacy Sandbox. By explaining why we need the Privacy Sandbox. Many of you will know the backstory all too well, I'm sure, but it's worth quickly reiterating why we need this and how we got to where we are today. So this talk is going to be in three parts. First up, like how and why the Privacy Sandbox came to exist, the motivations for Chrome to take on this big project. And next, what's actually in the Privacy Sandbox, in particular, the ads APIs. So that's topics, Fledge, and Attribution Reporting. I won't go into too much technical detail, but I'll give a kind of conceptual overview of those. And lastly, if there's time, you're going to get some inside information about how the feature development lifecycle actually works. How these APIs are being developed, how we engage with industry and all the different ecosystems involved, and how you can help with that, get involved. So you might have heard this word composability, and this is really the web's superpower. You might have seen this example from Google I/O. This is a typical site with components from different sources. We have a map from one origin, some script from another, and of course, advertising. I mean, whether we like it or not, and whatever the future holds, advertising has become a crucial source of revenue and a driver for business on the web. I mean, at this point in history, I think that browsers need to support advertising use cases. And of course, advertising is not new, and serving relevant ads is as old as advertising itself. I found like these ads in the back of an old book, and this billboard that was on the highway on the right, doing relevant advertising back in the day. So, I mean, what's the problem now? Well, historically, the web has used cookies, as you know, and other tracking mechanisms to allow sites to deliver relevant ads. And of course, these mechanisms are going away. And that's a problem for interest-based ads, for remarketing or custom audiences, and also for ad measurement. So ad selection, conversion measurement, these other use cases have relied on cross-site identity using mechanisms that just weren't built with privacy in mind. I don't mean just third-party cookies, but fingerprinting is used to track user behavior across sites, and or else sites just request personal information like email addresses or whatever. And as you probably know, the ad ecosystem is really, really complex. Not even developers, or advertisers, or publishers understand the supply chain for third-party services. And certainly when I visit a website, I'm not aware of all the third parties involved and what they're doing with my data. And it's not just me. Research shows that people really care about being in control of their data. Privacy concerns increasingly drive choices about what people do online. And regulators around the world, of course, are stepping up privacy requirements. And, this is happening very quickly. Now, given how many businesses rely on effective advertising online and how many publishers rely on advertising to monetize their sites, this is a problem for the whole web ecosystem, and not just for tech companies and ad platforms. But because the web is an open platform, proposals for change need buy-in and feedback. And browsers such as Chrome cannot and don't want to act unilaterally. Browsers are not products for which browser vendors can make decisions in isolation. So the reality is that the web was not designed for many of the requirements that are core to the platform today for advertising, fraud detection, identity management, and many other use cases. We need purpose-built technologies for this new privacy-focused web, and that's where the Privacy Sandbox comes in. So Chrome has been working with web community and industry stakeholders and regulators to develop new privacy-preserving technologies that can support a healthy, sustainable ecosystem. Now, once these new purpose-built APIs are available, we need to make sure companies have time to adopt them so that then we can safely phase out support for third-party cookies in Chrome and continue our work to mitigate other types of tracking. So the core set of principles for this initiative is the potential privacy model for the web. This has been developed by privacy experts and computer scientists from Google. The privacy model lays out a set of ground rules, really, for designing technologies that meet the web platform use cases I've talked about, while also abiding by our changing privacy needs. In particular, the proposal covers the difficult question of how to enable connections across sites without compromising privacy. Now, one of the major innovations of the Privacy Sandbox APIs is to enable the browser to act on the user's behalf. In a sense, we're getting back to the browser's core role as what you think of as a user agent. With current technologies, data is collected, aggregated, shared by third parties to track user browsing across sites. Privacy Sandbox APIs can allow ad auctions, conversion measurement, and other use cases to be fulfilled by the user's browser on their device. Now, with all that in mind, I'm going to give you a whistle-stop tour of the actual Privacy Sandbox APIs. And by the way, we've been really pleased with engagement we've seen so far. Just a few numbers to highlight here. Just bear in mind that these numbers primarily show, early stages of incubation and design, that part of the process, since that's been the focus of course, the first phase of the initiative. Now, I won't go deep into the development process today. I just want to give you a glimpse of how that works at a high level. The process is staged and iterative, starting with public discussion of early proposals, and then moving to initial prototypes, which, of course, undergo multiple rounds of feedback and testing. And we've got 12 proposals, I believe, at various stages of development in this process. Today, there are 5 Privacy Sandbox technologies which are available for public testing, including the 3 main ads APIs, topics, Fledge, and attribution reporting, which I'm going to talk more about today. So here's the public timeline that's available at privacysandbox.com. There will be lots of milestones over the next 2 years. The big ones to notice here are mid-2023, when we expect the APIs to be launched in Chrome for general availability. So that's in Chrome Stable. And then H2 2024, when we expect to begin phasing out third-party cookies. Now, we're expanding our communications channels to provide stakeholders with information they need. We have developer guides, live office hours, email groups for the APIs, W3C meetings, discussions on GitHub, and reports to regulators. And I'll share URLs for all this at the end of the presentation, so you can get more involved if you want. So yeah, the Privacy Sandbox, I don't know, the APIs have a lot of work to do to provide these purpose-built APIs to support this variety of use cases. I'm going to focus on use cases for advertising that are addressed by Privacy Sandbox. So to show relevant content, like I said, and digital ad measurement of efficacy. Just quickly, first, some basic concepts and assumptions behind these proposals. If you're reading any of this stuff, just to bear this in mind, if you read anything about online advertising, you'll see these words like advertiser and publisher. So in this context, when we talk about an advertiser, we mean a site that wants to buy advertising space to advertise its products or services. And then a publisher is just simply any kind of site that sells ad space. Now, advertisers, of course, need ads to sell their products or services, and publishers need ads to get revenue to support their sites. Ad tech platforms manage buying and selling of ad space and the measurement of digital advertising. And they work on behalf, of course, of advertisers and publishers to buy ad space and to sell ad space. Now, evidence from research, not surprisingly, shows at least, well, 3 good reasons why we need relevant advertising. Relevant ads are less annoying to users. That may seem like common sense, but it's research shows that as well. And of course, relevant ads can be more useful to the people who see them. Advertising gets more engagement and interaction when it's relevant, and that's always been the case for advertising well before the internet was a thing. So in a web context, there are different ways to improve the relevancy of ads. I don't think I'll go into this right now, but just bear in mind that there are these different mechanisms for providing relevant ads. All these mechanisms play their role. Like, I was talking to Yanis about this before. Like, if you love collecting stamps, you might spend a lot of time on sites for stamp collectors, say. But there are only so many stamp-related ads that these sites can show you. Contextual relevance, in other words, is just often not enough. So we have these other mechanisms for providing relevant ads. So there are 3 main advertising APIs in the Privacy Sandbox. So that's Topics, Fledge, and Attribution Reporting. And Topics and Fledge are known as the relevance APIs. Topics provides these high-level signals of a user's interests based on their recent browsing history. Topics can be combined, of course, with contextual signals and first-party data to select relevant ads. Now, Fledge supports more granular remarketing and custom audience use cases, where marketers want to reach audiences who've shown interest in specific websites or products, but in a way that makes that possible in a privacy-preserving way. Attribution reporting, it's Chrome's proposal for privacy-preserving campaign measurement. In other words, measuring efficacy of ads, but providing anonymized performance reports when people view or click on an ad, and then when they later go on to complete a purchase. So these 3 Privacy Sandbox ads APIs are now available for testing in an origin trial. I'll explain what that means when I talk about the feature lifecycle. So as part of the origin trials, Chrome is also providing updated user controls for testing. Now, just to set some expectations, the most important thing to remember is that these are just, these are proposals, not a final plan. The proposals, of course, are evolving with community feedback and testing. So first up, tell you a bit about Topics. This is an API to enable interest-based advertising, but without resorting to tracking the sites a user visits. So here's how it works. In the browser, on the user's device, Topics maps each website host name a user visits to a limited set of topics available from a human-curated and publicly visible list. For example, a website might be associated with a fitness topic. There are currently a few hundred of these topics, but that's evolving as we go through testing. And then on a weekly basis, the browser on the user's device collects the user's top 5 topics from the past week based on the participating sites that the user visited. Now, when an API caller, so for example, an ad tech platform calls the topics API in JavaScript, that can return up to 3 topics for the user. One topic chosen randomly from the top topics for the most recent week, plus 1 topic each for the 2 prior weeks. And then, of course, advertisers can use those topics as a signal, to choose relevant ads. So just a bit more detail about how to make the website. Sorry, someone have a comment there?
No, it should be fine. Sorry, just a little bit of echo.
No worries. I'll keep going, but shout if it goes wrong. Anyway, just a bit more detail about how topics are inferred. So a machine learning model has been created to map website host names to topics of interests. Now, topics for the top 10,000 sites are actually curated manually, but for other sites below that, top 10,000 topics are inferred using the model. So and that model is downloaded by the browser to the user's device. It's not a very big file. You can actually view the model from the Chrome Topics internals page. And you can also actually take a look at the list of topics for the top 10,000 sites. So in the browser, running on the user's device, the API uses the model to infer topics of interest to the user. Chrome actually has a page to display topics information, Chrome Topics internals. In this example, you can see that I've viewed cat-related pages and the API has responded accordingly. You can also see technical information there about the current implementation of the API. And that's particularly useful when you're testing with flags, which I'll mention later. Now, you can also check from there what topics are inferred for a list of host names. So if you want to look for your site and see how well topics works for that particular host name. Anyway, we have lots of resources available if you want to find out more about the topics API. You can dig into our overview of the API or find out how to experiment with it. We've got a demo you can try out. If you want to go deeper than that, then you can read the proposal and give feedback. So next up, Fledge. This is an API for on-device ad auctions. So this serves remarketing and custom audience use cases, but without the need for cross-site third-party tracking. Now, I want to go into a little more detail with this because it has a more complicated job to do than topics, but I won't go technically too deep. I'm going to give a sort of conceptual overview. So anyway, there are 3 parts to the Fledge process. First, the ad buyer. This is whoever this is that's buying ad slots for an advertiser. So they add users to what are called interest groups. And these are like custom audiences, but interest group membership is stored on the browser on the user's device. Now, at some point, an ad seller, so this is whoever it is that's selling ad space, might be an ad tech platform or possibly a publisher itself. They will initiate an ad auction, which can be run on the user's device. Now, to select an ad, the auction code runs bidding logic from buyers and auction logic from the seller. And then lastly, the browser does post-auction reporting to endpoints that are supplied by the seller and the buyer to see how the ad auction went. So I'm just going to go through that briefly, step by step. I'm going to show a tiny bit of code. I won't go into detail though, but don't worry too much about what that means. So first up, imagine a user visits an online shoe store and does some browsing. Now, an ad tech platform or an advertiser itself makes a JavaScript call to tell the browser to join an interest group. Yeah, this might be named something like trail running shoes. And then the advertiser or its ad tech platform does that by using the Fledge API. And in this case, the shoe store's ad tech might have an interest group for remarketing they'd like to add the user to. Now, the shoe store's ad tech platform, like I say, calls join ad interest group to ask the user's browser to join their trail running shoe interest group using the configuration I showed, and they can cap the time that interest group is available. Now, next up, the user visits a site that publishes ads, in this case, a news website. An ad auction is run in JavaScript on the user's device by the seller using this run ad auction method, probably an ad tech platform, but maybe the publisher itself, in this case, say a news website. And the auction selects the most appropriate ad given the bids for each of the user's interest groups, and other factors from the seller and also data from the browser. I won't go into the code here, but you can look back on this if you want to look at the presentation. So the value returned by the ad auction code is passed to an element called a fenced frame so that the site can display the winning ad. Now, this is nice because the fenced frame can be used to display an ad, but it cannot interact with the page around it. So that keeps it more private and more secure. And lastly, the seller and the winning buyer can each have an opportunity to perform logging and reporting using the method here. Now, the user taps or clicks on an ad if things go well. And now at this point, the Attribution Reporting API takes over. Just before I go to that, a couple of obvious questions. What's an interest group? Well, kind of does what it says on the tin. It's like a custom audience or remarketing list. It represents groups of people who have already visited an advertiser site. Each interest group has an owner that's acting as a buyer, like to ad slots, on-device ad auction. In other words, interest group owners are likely to be advertisers or the ad tech platforms that work for them. Like I say, aiming to buy ad inventory, ad slots in ad auctions. And an auction, like I say, is a little JavaScript program the browser runs on the user's device to choose an ad. To help keep auctions secure and private, this JavaScript code is run in what are called worklets, which are tightly constrained and have no access to the JavaScript DOM or the network, or essentially can have any other side effects. So yeah, that's a very quick overview of Fledge. You can find out more from the resources here. There's a relatively non-technical overview and a developer guide. And of course, you could read the proposal explainer itself, which goes into much more technical detail. We also have a couple of demos for Fledge. And again, I'll share these links after the presentation. Now, finally, at the end of the funnel, we have attribution reporting. The Attribution Reporting API makes it possible to measure when an ad click or view leads to a conversion, such as a purchase on an advertiser site. Now, it's designed that it cannot be used by third parties to track user browsing behavior across sites. So today, digital ad measurement is enabled by building a per user cross-site identity using third-party cookies and other identifiers. The ID for a user is sourced from the browser by third parties. Cross-site data is matched and then aggregated to work out advertising efficacy. Now, the goal of Privacy Sandbox is to enable the use case, the end use case there, working out the efficacy of advertising, but without exposing the sensitive user level behavior of users. So the Attribution Reporting API does this by moving the work of recording and matching ad events and conversion events from external parties to the user's browser on their device. So I'm going to go over this very, very briefly without really any technical detail at all. So first up, a publisher website can configure ads by adding a special attribute to add elements. And that means that when a user clicks an ad, the user's browser keeps a record of that on the user's device. And later on, if the user interacts with the advertiser's site, the browser can record that event as well. Now, through all this, there are multiple privacy measures in place to ensure that users can't be tracked. In case you're wondering, noise means just that a small percentage of cases, random data is sent. And then finally, aggregatable reports allow you to collect detailed conversion side information, such as exact purchase values, geographical location for the conversion, and so on. And then event level reports give you access to course conversion side information, such as a conversion type like purchase or product page visit, whatever. So that's a very quick overview of attribution reporting. I really recommend the articles by my colleague Maud on developer.chrome.com. And again, yeah, we'll share URLs for these later on. So I'm aware I have about 4 and a bit minutes.
Yeah, a bit less, yeah.
I'm going to quickly just go very quickly through something about the feature lifecycle for how these APIs go from being an idea on a piece of paper to actual code that runs in billions of browsers.
Can I just ask briefly if it's possible for the advertiser to know how large an interest group is?
How many browsers they've managed to add to that?
Yeah, so how many have this, trail running shoe interest group?
Yeah. So each time they add a browser to an interest group, they'll get a confirmation of whether that call was successful or not. So they can keep a record of that.
Okay.
I mean, simply that the event of calling, that was successful.
But as an advertiser, would I know how many are interested in, how many are in this interest group versus that interest group?
Yeah, so the ad tech platform could keep a record of which, of the number of browsers that were where that code was called to add a user to an interest group. So that would be held probably by the ad tech platform or the advertiser.
All right, perfect.
I mean, there are publisher use cases for interest groups as well, but I won't go for them now.
All right, thank you.
Anyway, I'm going to rush through this a bit. So just explaining how we get features from start to finish. In other words, how these things go from idea to actual code. Okay, there's this way this new feature, say, makes its way into Chrome. Well, the Chrome team starts out with a proposal. They write in a Google Doc. They publish a proposal, explainer on GitHub, and then engineers code the proposal in Chrome Canary and Dev, and then Beta for testing. And eventually the new feature makes its way into Chrome Stable. Well, that's really simple. Unfortunately, of course, what's entirely missing from this whole that diagram is feedback and iteration. And that's where, your experience, anyone on this call, whatever your business, can be incredibly valuable in that testing and iteration process. And that's what, of course, Chrome really relies on at every phase there. So I'm going to go through a little bit in more detail at each stage of that. First stage of updating web platforms is consider requirements and principles, developing a proposal. For something like Privacy Sandbox, this comes in 2 stages. Have idea incubation. And this is where it all begins. This is the actual document that was the start of the topics explainer. This was the Google Doc, you can imagine, with many, many comments and replies. And a lot of discussion and refinement happens at this stage. Within internal teams, engineering, legal, DevRel, partner teams, so on and so on. Now, if all goes well, that leads to a public proposal called an explainer, which is published on GitHub, like this one for topics. And this is when public interaction begins. So firstly, on issues within the explainer repo on GitHub, anyone can post questions and comments on the design of the API here. So just to reiterate, this is when the API is just at proposal stage. The design is under discussion. No code has actually gone into the browser here. So here, for example, is the first item on the page from the previous slide. And, each one of these issues will be viewed by the proposal authors and get, really, I would say, robust discussion from anyone who wants to join in, usually developers and technical stakeholders. Now, you might have noticed, by the way, the topics explainers published on a repo from the PATCG. That's the Private Advertising Technology Community Group. It's part of the W3C. And in case you're wondering, the W3C is the World Wide Web Consortium, which is I guess you could call the standards body for the web. It's led by Tim Berners-Lee, and it's a consortium with engagement from lots and lots of other organizations, including Google and Chrome. Now, they have monthly online meetings to discuss proposals, and this is a really good place to get involved more deeply in discussions about API and API design, but also the kind of overall direction of online advertising and web platforms in general. So once the proposal has been discussed and refined, it's still just words on a page. The next stage, of course, is to actually write code and to prototype and test that code in the browser. So the Chromium Blink Dev mailing list will announce this with an intent to prototype. And then at this point, there will be announcements on other mailing lists and will be some discussion in these groups, but mostly, really for important updates. And you can subscribe to these if you're following particular APIs. So yeah, at every stage of this process, you can encourage your teams to find out where and how to provide feedback on the APIs. We have a page for that, and I'll link to that later. So just to be clear, this testing phase initially takes place with code going into Chrome Canary and then through a process of iteration through each of the Chrome channels, so dev and beta, and then finally we get to where we go into Chrome stable. And of course, new features aren't released to all users all at once. That would be incredibly risky. So during this phase of testing, features are only activated for a proportion of users. So you might hear phrases like this, features being rolled out to a proportion of like 1% of users. And this uses a mechanism called Chrome variations. You might have heard of this also referred to as field trials, or possibly their internal code name, which is Finch. But that allows us to roll out changes, new features to a subset of users. And of course, large scale, I don't know, like large scale software like Chrome, goes through rigorous automated and manual testing at every stage. But just bear in mind that the Canary, Dev, and Beta channels are mostly used by developers, and Chrome stable users use Chrome at much larger scale and in different ways from these testers. So Chrome variations is actually a crucial mechanism to help testing in Chrome stable, making it possible to check usage and metrics in Chrome used by normal, ordinary, everyday users with a feature either activated or deactivated. I won't go into too much detail there, but we have links for this. You can also use Chrome flags to enable or disable flags for individual testing. I won't go into detail about how you can do that there. That's something for your developers. So at this point in the life cycle, we have an experimental version of Chrome running, of an API running in Chrome. Individual developers activating the API by setting flags. An example there from topics. We have multiple mechanisms for reporting bugs in Chrome for the actual implementation, but then also reporting comments on the API design itself. Yanis, are you all right if I run? I have about 2 more minutes, I'd say.
Yeah, I think we'll do 2 more minutes. I know you managed to stretch a 2-hour presentation into 35 minutes now. It's totally fine.
Great. I will be there shortly. So like, speaking of which, like thinking about bugs, I actually found a topics bug by playing with the demo. And, you can see we have demos here, which are great for your developer teams. They are, however, not designed for consumers or non-techies, but they provide a lot of valuable feedback. So the crucial thing here is that after we have this kind of individual developer testing phase, we get to what are called origin trials. And this is where we get into small scale testing with real users beyond individual developers, just trying out the APIs. So for those who haven't heard of them, origin trials are a way to test a new feature or experimental web platform feature. Developers can register for an origin trial and straight away get a token. It's just a string of letters and numbers. And the origin trial feature is enabled on every page that provides a valid token. Now, that enables sites to test a new feature at scale with all or some of their users. You can find out more from the page here, and I'll share that URL later. But for each origin trial, an announcement is made on the Chromium.org Blink Dev list we have what's called an intent to experiment post. And that means that, the author of a new feature would like to run scale testing as an origin trial. And yeah, for each origin trial, you get a registration page on developer.chrome.com where you can sign up to take part in those. So this is where we are now for the Privacy Sandbox APIs. They're available in an origin trial for 50% of users on Chrome Canary, Dev, or Chrome Beta, and 1% of stable users. That's on desktop and Android. So in other words, Chrome Variations is being used to make the origin trial available to a subset of users on each of the Chrome release channels. So alternatively, as I mentioned, of course, you can enable the APIs for a single browser, for a single user like yourself, by setting flags from the command line or from the Chrome flags page. You can find out more about origin trials on developer.chrome.com from the URL there. I've also been making a series of short, relatively non-technical videos about these Chrome concepts. There's one about origin trials. And yeah, so really just to sum up here about Privacy Sandbox, we've been through this period of technical testing with the APIs activated using Chrome flags for individual users, and initially for this small percentage of users, as the origin trial has been activated for only a small percentage of Chrome users. So now we're at the stage of what we might call utility testing. 50% of Chrome Canary Dev beta users have the ads origin trial APIs activated on pages that provide a valid token, and 1% of stable users. So that's a very small percentage of overall Chrome traffic, but can be enough for limited testing of the APIs with real users. So assuming all goes well, the APIs will eventually launch in Chrome Stable and to be activated for all users by default. So thanks for listening. That's it from me. Like I say, I'll share the URLs after event. You can find an awful lot of the content I've talked about from this URL, goo.gle/ps. PrivacySandbox.com has like timelines, FAQs, more information about cross-platform efforts. And yeah, the videos I mentioned explaining these concepts like origin trials and Chrome flags at goo.gle/cc. I haven't mentioned at all Privacy Sandbox for Android, but that is a thing. And if you look at the deck here, you can find out more information about that. So yeah, right. Thanks very much. That's it from me.
Thank you, Sam. Thank you very much. Let's finish up with just a brief question, which I think you can answer almost yes or no. And that's from our member, Jack Diego in the US. This grouping concept, is that being applied to the upcoming change in user agent data that's sent by Chrome browsers too? Did you see that in the chat, Sam?
Let's have a look.
Or Jack, do you want to?
So there are different projects here. One is the sort of set of projects about making sure that user agent data can't be used for fingerprinting. So there's a separate part of the Privacy Sandbox initiative that's dealing with that. And then, separate to that, we have Fledge, which is this way of bringing in a concept of interest groups where we can, meet these, like I say, remarketing and custom audience use cases. So they're kind of slightly separate concepts. The point is to be able to do that in a privacy preserving way where we can get away from, the problems we've had with technologies like the user agent string being used for fingerprinting. So yeah, there are two separate things going on there, but they are certainly related. Fledge helping us get away from fingerprinting that uses stuff like user agent data.
All right. Thank you, Sam. I think that's all for this brief time. Thank you so much for finding the time to share with us. I really appreciate it. And
thanks for having me. Thanks so much. Great to see everyone.
Certainly be following the progress, but thank you for sharing with us. I think this is really important and really good to see. So I think this is a key building block to understand, and as we improve the web.
Indeed, yeah. Yeah, watch this space. There's a lot of, I don't know, a lot of interesting stuff happening, a lot of really good work. And you know, I work with these teams, and there are, I would say this, but there are very good and very clever people working on these projects, and they're very complex. But you know, I think there's been a lot of progress, which is great to see.
Thank you, Sam.
No worries.